A relation is a set of ordered pairs. Anytime we have an equation, we can look at the input, the x value, and the output, the y value, as being a relationship that function, that equation signifies. A more generalized way of thinking about equations are as functions. A function shows that relationship between the two variables for which one value is the input and the other one is the output. So we can write y equals 2x as an equation, but we can also write f of x equals 2x, which you see here, to also represent that equation. But now we're using what's called function notation. This actually gives us a little bit more flexibility than always saying y equals for every type of relationship that we might be dealing with at the same time. Now there is some vocabulary. First of all, the input values are called the domain. So the domain is the set of all the different input values that will work for that function. The output values are called the range. They are all, if you will, the outputs. You can simply think of this just the way you would if you went to an ATM. You push the buttons, that's your input. You get the money out, that's your output. Here's another example of a function. Here we have f of x equals 3x minus 1 if f equals 4. So now how, instead of writing f of x, we write f of 4. So that means wherever we had an x in the relationship, we're now going to put in a 4. Well, 3 times 4, that'll give us 12. 12 minus the 1, that gives us our 11. So if x is part of the domain, where f of x equals 11, and then the output, the 11, is part of the range. On a graph, the x values are always the horizontal values, if you will, and the range are always the vertical values, or the y values. Now, if you have things written as ordered pairs, xy pairs. So for instance here, 2, 1, 4, 3, negative 1, 3. Those could, of course, represent points on a graph, but they can also represent the input and output values of a function. Likewise here, 2, 1, 2, 4, and negative 5, 6 could represent another group of ordered pairs. However, they cannot be the input and output of a function, because in fact, for every single x value, we can have only one y value. And so note, in our first set here, 2 gave us a 1, 4 gave us a 3, negative 1 gave us a 3 here. Yeah, we have two different x's. They gave us the same y. That's quite all right. But in our second group, this 2 gave us a 1. A 2 also gave us a 4. So imagine going to your ATM and you want to get out 20 bucks, and sometimes it gives you 40 bucks and sometimes it gives you 20 bucks. You never know. That would not be a satisfactory situation in the long run. So with a function, again, different values of x can have the same y, but only one value of x can result in one value of y. So it's got to be this kind of one-to-one thing. F of x is said to be increasing as long as between any two x values, x1 and x2 in this case, the outputs are also increasing, and it is decreasing when we put in the x1 and x2 if the outputs are decreasing over that same interval. So, mostly, for our purposes, this is just another name. So instead of going y equals 2x or y equals x squared, we're going to be going f of x equals 2x, f of x equals x squared. And then outside of what are domain and range and whether or not it's a function, pretty much everything else will be the same as what we've already encountered. Now, for each of these first 4 examples, we want to say whether or not it is a function and what is the domain and range. So first off, for the domain, remember that it is the x values. And so in this case, x is equal to the set. Well, we have 3, 5, 2, and negative 5. And then the range, well, that's the y values. Those are the second numbers in each ordered pair. And so our y's are equal to 1, 7, 3. There really is no reason to put the 7 again. It's already part of our set. And then, since every x is different, this is a function. The only way to tell that it's not a function is if we had the same x and different y's. Well, all our x's here are different, so as far as we can tell, that's a function. Now, another group in number 2, and so again, our domain, the x's, and so I have 5, 3, I have 5 again, and a 1. The range, well, that's the y's, and I have -2, -1, -3 as the second numbers in each ordered pair. Now, here I have a 5 that gave me an output of -2, and here I have a 5 that gave me an output of -1. 2 different y's, for the same x, not a function. Now, when we have graphs, we are going to take, if you will, some little liberties in terms of our values. First of all, even though we can't be sure, we're just going to say that it starts there and it ends there. And we're going to go ahead for our purposes and just say those are on whole numbers. So for the domain, and again, the domains are going this way. Well, on this end, we start out at -8. And again, it's the x values. And then we end up at +9. Our range, well, those are going to be from the highs to the lows. The highest point looks to be about right there. Actually, it's right here. That's the high point, and the low is down here. So 1, 2, 3, 4. It looks like the y's are going to be up to 4, and 1, 2, 3, 4 down to -4. And so there's our range. And since this is a continuous line, then we have to include everything that's in between. And so that's why they're written in that form. Now, when we have a graph, there is a very simple test for determining whether or not it is a function, and it is called a vertical line test. If anywhere you draw a vertical line test, if anywhere you draw a vertical line, it only hits once, then it is a function. And it doesn't matter that in some places you can only hit it once. If anywhere on your graph it hits more than once, then it would not be a function. So over here, as an example, if I draw a vertical line, okay, hits twice, so not a function. And for this one's domain, we're going to start from over here. Looks like we end up over there. So again, domain, the x's, looks like -8 again, and then up to 1, 2, 3, 4, 5, 6, +6 on that side, and then the range, 1, 2, 3, 4, so it looks like -4, and again, range goes with y's, and it's up to 7 for our range. So when it's just ordered pairs, domain is the first part, range is the second part. When it's a graph, domain is left and right, range is up and down. We can use the vertical line test to tell if it's a function or not. Now, what if we get an equation? Well, basically the idea for an equation is it's going to be based on input and output. So what kind of values can we input and what kind can we output? Now, most of the time, the input's going to tend to just be, again, x. It's going to be all real numbers. In other words, in this equation here, I can put in positive, negative, positive x's, negative x's. I can put in 0. There's no limit to the values of x that I can put in. However, for the range, I'm not going to actually get all possible numbers. Simply put, this part here is always positive if it's set up so that this part is 0, okay, then y is going to be -5. Okay, if x is positive, absolute value will keep it positive. That'll still be a positive number. Subtract the -5, so it's going to be bigger than -5. On the other hand, if I put in negative values of x, the absolute value will still turn it positive. So I'll still have a positive number, subtract a negative number. So again, it's going to be bigger than -5. So basically, what this means is that y has to be bigger than or equal to -5 in all cases, because the smallest this is 0. Absolute value would be 0 or a positive number. And therefore, 0 minus 5, well, that'll give me my minimum, but I'll be everything above that. Now, for this one, and, oh, by the way, it will be a function. For this one, again, there is no real handicap or limit on what I could put in for x. So x will be the domain all real numbers. Now, again, what about this part here? Well, since it's got a square, that means if what's inside the parentheses is positive, it'll be squared. It'll still be positive. If it's negative, like say 0 subtract 3, that would be -3. but the square is going to end up making it positive again, and therefore it'll still be positive. In fact, the smallest I could make this would be if x equals 3, then I'd have 3 subtract 3, which would make that part 0. And so in this case, the smallest that this is going to be is 2. Anything else, any other x except x is 3 is going to give me a situation in which this is bigger than 0, and therefore this is bigger than 2 as a result. Now the last part of these asks where is increasing and where it is decreasing. So the way to look about that is in terms of take the part that's in absolute value, or take the part that's in the parentheses, and think in terms of where it's 0 and how the numbers on either side of what makes it 0 will work. So, for example, let's start off with -4 will make this part 0. Okay. Now, what if we have -5? Well, -5 and 4 will be -1. Absolute value will make it +1. 1 minus 5 will be -4, so it'll be a little bit bigger. Okay, and we're going to go from there. So what if we make it -10? Well, -10 and 4 will be -6. Absolute value make it +6. 6 minus 5 will now be 1. So anywhere basically from -infinity, so more and more negative numbers, up to when it was -4, this will be decreasing. In other words, our output value will be less and less. But the 0 is at -4, so once we get past that, anything from -4 and then up to positive infinity will be increasing. The values will get greater and greater. And again, the key is where does that absolute value part equal 0? I'm going to do the same thing over here. Here, of course, it'll be where it's 3. That's where we get the 0. So any negative number below -3, so -4, -4 minus 3, -7, -7, that's a squared, 49. -5 minus 3, -8, -8 squared, well, that's now 64. So we're going to end up with, as long as we're going from -infinity up to the 3, we will be decreasing in our values. Again, when I got a bigger -x, it gave me a bigger answer. So as I approach 3, they're going to be decreasing. And then once I get on the other side of the 3, and so now it's 3 up to positive infinity, then all our values will be increasing. And so that's the idea there. Now, this last little bit just wants us to do what's called an evaluation, which just means basically you plug in the value for x. So what you see inside these parentheses, that's the value of x. So let's just plug them in. So f of 3 is 8 times 3 over 3 minus 5, which of course 3 over 3 cancels, so it's 8 minus 5, which would just be 3. And then f of -9 equals 8 times -9 over 3 minus 5. The 9 over 3 will cancel to give me -3. -3 times 8 is -24. Subtract another 5, -29. And then f of 0 Means wherever we have an x, plug in 0. So 8 times 0 over 3 minus 5. And of course, anything times 0 is 0, so we just end up with negative 5. For our second example, f of 3 is going to equal 3 plus 6 squared, subtract 15. 3 plus 6, of course, is 9. 9 squared, 81. 81 subtract 15 is 66. F of negative 9 plus 6 squared, subtract 15. Notice the only thing that's changing is what I plugged in for the x. So here, negative 9 and 6 is negative 3. Negative 3 squared is 9. 9 subtract 15, negative 6. And f of 0 so that'll give me just the 6 squared, 36. 36 subtract 15, 21. So a couple things to note and finish here is, first of all, I like to use parentheses or brackets to designate, hey, here's where I plug something in. And then secondly, just because I have f of 0, as you can see, it does not have to equal 0.